Hello, in this video, I will be explaining question number 5. Explain the key difference between k-mean clustering and hierarchical clustering algorithms. What are the advantages of hierarchical clustering over k-mean when visualizing cluster relationships? Aspects clustering type. K-mean clustering has partial partitional divides the data into k non-overlapping clusters. In hierarchical, agglomerative, bottom-up, or divisive, top-down builds a tree-like structure of nested clusters. Number of clusters in k-mean, we have predefined number of clusters, and in hierarchical, there is no need to predefine the number of clusters. Approach in k-mean, it will be iterative approach where data points are assigned to cluster based on centroids. In hierarchical, it starts by treating each data point as a single cluster. Then cluster shape. It assumes a spherical cluster tends to perform poorly with non-spherical, and in hierarchical can form cluster with complex shapes works better for non-spherical clusters. Computational complexity, where O n into k into t, where n is the number of data points and k is the number of clusters and t is the number of iteration. And in hierarchical, O n to the n square or O n cube. Depending on the implementation, hierarchical clustering can be more computationality expensive for large data set. Scalability. Scalable well for large data set, and hierarchical can be slower computationally expensive for large data set. Distance metrics requires a fixed distance metric to calculate distance between data points and centroids, and hierarchical more flexible with choice of distance metric. Output produces k clusters. Each data point belongs to exactly one cluster, and in hierarchical produces a dendrogram, a hierarchical tree structure showing the merging or splitting process. Handling of outliers. Sensitive to outliers as they can significantly affect the centroid calculation. In hierarchical, less sensitive to outliers since the clustering process can be more robust, but outlier may still affect the dendrogram. Cluster assignment assigns each data point to specific cluster based on the final centroid. And in a hierarchical, each data point is represented in the tree, and cluster can be predefined by cutting the dendrogram at the desired level. Advantages of hierarchical clustering over k-mean. No need to predefine the number of clusters. First, hierarchical clustering does not require the number of clusters K to be specified in the advance. The tree-like structure allows you to decide how many clusters to create after examining the data. This flexibility is beneficial when you do not have prior knowledge of correct number of clusters. K-mean requires predefined number of clusters, and choosing the right value for K can be challenging without prior insights. Second, cluster hierarchy and nested structure. The dendrogram generated by hierarchical clusters showing the relationship between clusters at different levels. This visual representation helps you understand how clusters are related to one another, which is especially useful for identifying nested structures and subclusters. K-mean only provide a flat clustering, which makes it difficult to visualize the hierarchical relationship between clusters. Third is ability to visualize complex relationship. Hierarchical clustering allows better visualization of data points and clusters are connected in hierarchical manner. By cutting the dendrogram at different levels, you can view clusters at different granularities. K-mean, on the other hand, simply partitions the data into K clusters without providing any information about how clusters relate to one another. Fourth, interpretability of relationship. The dendrogram offers insight into the structure of the data. You can visually explore which clusters are similar or dissimilar, as well as understand how difficult cluster merge or split as the algorithm proceeds. This is particularly valuable for understanding complex datasets with inherent hierarchical relationships. K-mean only gives the final cluster assignments and centroids without any context about how clustering were formed or how they relate to each other. Flexibility in distance matrix choice. Hierarchical Clustering is more flexible in choosing different distance metrics. This makes it suitable for a variety of datasets, including non-Euclidean data. K-mean typically uses Euclidean distance by default, which may not be suitable for all data types. This is all for this video. Thank you for watching.